So friends, today we will calculate electric field inside an uniformly charged sphere. Yes, inside an uniformly charged sphere. In our previous video, we have calculated electric field outside an uniformly charged sphere. But today, we will calculate this electric field for inside uniformly charged sphere. So what we have? We have a sphere, uniformly charged sphere, that is having the radius capital R. Now, if we want to calculate electric field inside this uniformly charged sphere, we have to consider what? The first step is we have to consider a Gaussian surface. Gaussian surface that is having radius smaller, where smaller less than capital R. This is Gaussian surface. So when we are going to calculate electric field inside or outside, today's case is inside the electric field, inside the uniformly charged sphere. So when we are going to calculate electric field inside an uniformly charged sphere, we are considering a Gaussian surface that is having radius smaller and that has radius smaller less than capital R. So after considering Gaussian surface, that means what? That means we will consider Gauss's law here. So actually, what is Gauss's law? Gauss's law is closed loop integration E dot ds equals Q enclosed, means enclosed charge, by epsilon naught. What is this E dot ds? You know electric field E, and ds is the area vector. So what it gives? It gives the flux through area. So we will apply this formula to obtain electric field inside an uniformly charged sphere. So okay, let's carry on. So E dot ds, what we are first trying to draw very small figure here. Here it is the actual uniformly charged sphere, and here and here let me draw the Gaussian surface, and here inside a Gaussian surface of smaller radius. So now applying Gauss's law, so smaller radius having the area what? Smaller radius is having the area of 4 pi r square. Yeah, because you know, let me check it. Okay, E dot ds cos theta. Here actually electric field is radius direction, so E dot ds cos theta, for theta equals 0, E dot ds cos 0. That means here they are radially electric field. We are trying to obtain radial electric field. So electric field vector and area vector both are in same line, both are parallel, you can say. So they have theta equals 0, so cos 0, that is 1. Yeah, cos 0, that is 1. So now we will apply Gauss's law. So after applying the Gauss's law, we will get what? After applying Gauss's law, first we will calculate the area for small Gaussian sphere. The area is what? We are first obtaining the value of magnitude of the electric field, and area is 4 pi small r square, and Q enclosed. Now this is the main thing, Q enclosed by epsilon naught. What is the Q enclosed? Inside smaller radius, inside the Gaussian surface, and that surface has radius smaller less than r. So Q enclosed equals, here will be first Gaussian surface of smaller having radius smaller. What is the volume? 4/3 pi smaller cube. Yeah, 4/3 pi smaller cube, but the total charge is inside the capital R radius. Total enclosed charge is inside the uniformly charged sphere, na? So I am writing the charge enclosed expression. That is very much important here. So writing the charged enclosed expression, that is Q, and that is per what is the full volume? Full volume is of capital R radius 4/3 pi r cube. You all know. But we have to calculate electric field where? This is 4/3 pi r cube. To calculate electric field, that small region of Gaussian surface, that is having volume what? 4/3 pi smaller cube. So 4/3 pi, 4/3 pi, 4/3 pi, 4/3 pi will be cancelling out. So what will be the enclosed charge? So enclosed charge will be, let me clear it first. Enclosed Q enclosed charge will be Q into small r cube by capital R cube. Now we will put this Q enclosed charge in that formula that we are obtaining the electric field, by which we are obtaining the electric field inside an uniformly charged sphere. So applying that formula, we will get, let's apply the formula. Yeah, let's apply. E and cos theta have 0, we have obtained 4 pi small r square. Q enclosed is what? Q into small r cube into capital R cube divided by small epsilon naught. So what will be the electric field? This will be what? Q smaller cube epsilon naught. This is permittivity in free space. Now we will calculate electric field. E into, so what we are getting? E into 4 pi r square equals Q into small r cube by epsilon naught r cube. Small r square r cube will be cancelling out here. QR by epsilon naught r cube. So what will be the electric field? So after calculation, what we are getting? We are getting electric field will be, that is E equals, we are only taking the magnitude here, okay, because we know that it is radial component. So our aim is to obtain magnitude here. E equals Q into smaller cube by 4 pi, here it is epsilon naught, 4 pi smaller cube, here it is actually smaller cube and smaller cube cancelling out, na? Yeah, let me calculate. Okay, Q into smaller divided by 4 pi epsilon naught capital R cube. Q into smaller divided by 4 pi epsilon naught capital R cube. Let me write it clearly. So electric field inside an uniformly charged sphere, what is its magnitude? Q into smaller is having the Gaussian radius, by 4 pi epsilon naught capital R cube. So it is, yeah, it is the actual electric field inside an uniformly charged sphere. So thank you.